Okay, so inverse functions. So we're going to talk about inverse functions, how to find the graphs and the formulas. So functions, as we've seen, can be represented as a formula, takes x and gives it y. What happens when you switch the variables? What happens instead of having, say, y equals x squared, we change that to x equals y squared. Just flip the variables. So we're going to look at some graphs, and we'll go to a GeoGebra session. So we should be back from the GeoGebra session now. So what did we see from these examples? If you switch x and y in an equation, the graphs are related. They're reflections about the line y equals x. And if you start with a function y equals f of x, sometimes the graph we get by switching x and y gives us another function. And so that gives us these two rules. One, the horizontal line test means that a horizontal line hits the graph at most one point. And if a function passes the horizontal line test, then the graph that we get when we switch x and y is the graph of another function. The second function is called the inverse function of y equals f of x, and the symbol for that is this, f raised to the -1 of x. So does this function have an inverse? What is it, and can you draw it? It does have an inverse. Oops, sorry about that. It passes the horizontal line test. So that means if we reflect it over the line y equals x, we can figure out, we will get a function. So if we want to draw it, what would it look like? Well, this is a bunch of lines connected with, a bunch of points connected by various lines. The point A here is at -5, -5. If we switch that, the x and the y, we just get -5, -5. So that point stays where it is. So to get the graph of the inverse function, we just want to switch the x's and the y's. B is at the point -3, -2, -2. And if we switch the x's and the y's, we get -2, -3. So if x is -2 and y is -3, that means we get this point. We'll call that B prime, because it's the point we get when we reflect B around the line y equals x. C is the point 2, -1. And if we switch the x and the y, we get -1, 2. So -1, 2, that's going to be up here. And so that would be our point C prime. D is 4, 3. And if we switch those, we get 3, 4, just switching the x's and the y's. So x equals 3, y equals 4, that's up here. We'll call that D prime. So what does my inverse graph function look like? Well, we just connect the dots. A to B prime, B prime up to C prime, C prime up to D prime. And so there's the graph of my inverse function. So if this is y equals f of x, this is the graph of y equals f of inverse of x with a -1 there. Great, and so the line y equals x runs through the middle of it, and it's a reflection over that. So what's the domain of the original function? The original function domain starts at -5 and goes to x equals 4. The range starts at y equals -5 and goes up to y equals 3. What happens to the inverse function? Well, if you take the inverse function, you just flip the x's and y's, right? So the domain is going to be from x equals -5 up to x equals 3. And the range will start at -5. And then if we follow the inverse function, it's going to end at y equals 4. So switching the x's and the y's switches the domain and the range. So if you know one, you can figure out the other one. Okay, so another way to think about functions, right? We think about functions as being tables. Here's a table for y equals 2 to the x, minus 2, minus 1, 0, 1, 2. 2 to the minus 2, that's 1/4. 2 to the minus 1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. Sorry about that. So if we want a table for the inverse function, what we can do is we just switch the x's and the y's. So I'm just going to switch the columns. Y is 1/4. We had minus 2. 1/2, we have minus 1. Y is 1, we have 0. For y is 2, we have 1. And if y is 4, then x is 2. Generally, though, we want the first column to be x's and the second column to be y's, just to keep our notation straight. So we will relabel this as sort of 1/4, 1/2, 0, 1, 2, 4. Just renaming the y's into x's, and then minus 2, minus 1, 0, 1, 2. And so there's our inverse function written with x, and the second column is y. And we got that by taking our original function, switching the x's and y's, just flipping the columns, and then relabeling. So is the inverse a function? Well, yeah, you can tell it's a function because each x gets exactly one y. That's how you can tell from the table. So what does a graph of this look like? Oops, that's a terrible x-axis, but we'll live with that. X is minus 2, minus 1, 1, 2. When x is minus 2, y is 1/4. When x is minus 1, y is 1/2. When x is 0, y is 1. When x is 1, y is 2. And when x is 2, y is 4, which will be up there somewhere. And that gives us our usual exponential looking graph like that. What does the graph of the inverse function look like? Well, if x is 1/4, y is minus 2. If x is 1/2, y is minus 1. When x is 0, y equals 1. When x is, when x is 1, y equals 0. When x is 2, y equals 1. When x is 4, y equals 2. So you get the graph of the logarithmic function. That looks like that. And again, if you look at the line y equals x, these two are reflections in that line. And this is y equals 2 to the x. This is y equals logarithm base 2 of x. Right? And they're inverse functions. So what about y equals x squared? If we try to do the same thing for y equals x squared, we can flip the x's and the y's. We get 4, 1, 0, 1, 4. And then minus 2, minus 1, 0, 1, 2. And if we rewrite that, just relabeling the y's to x's, we get 4, 1, 0, 1, 4. And then this is minus 2, minus 1, 0, 1, 2. Is this inverse function, this table, does this table give me a function? How can you tell? And the answer is no, because I've got two x's that are the same, 4 and 4, but they give me two different y's. One is minus 2 and one is 2. So if we try to graph this inverse function, we'd start with x equals 0 and you get 0, but then at x equals 1, you've got a minus 1 for y and a 1 for y. Right? And so that's not going to pass a vertical line test. And if we have x equals 4, we have a minus 2 and a 2 for y. And so this graph, which is the graph of x equals y squared, it's not the graph of a function, because if you put in these vertical lines, it doesn't pass the vertical line test. And you can tell because we've repeated in the x column. So an important aspect of inverse functions is what happens if you do a function and then it's inverse, right? And in a sense, what this does is you take x and you go to y, and that's what f of x does. And then f inverse of x, the inverse function, just takes you back to x, right? It just switches the x's and the y's. So here's f of x equals y equals 2x. Here's the inverse function. So how do we calculate f inverse of, f of minus 2? Right? And we have to think about what the functional notation works. F of minus 2, you look in your table, that's 1/4, right? So this whole part here, that's just equal to 1/4. And that means now, once we know that that's 1/4, we go to the table for f of inverse and we look up what minus 2 is, what f inverse of 1/4 is. And f inverse takes 1/4 back to minus 2. Right? And so a way to look at this with tables, f takes minus 1 to 1/2. We look up 1/2 in the x column here. And then what does f inverse do? It takes 1/2 back to minus 1. F takes 0 to, that should be 1, and this should be 2. This should be 1, and that should be 0. This should be 2, and this should be 1. So take 0 to 1, and f inverse takes 1 back to 0. So it takes 0 to 0. Likewise, if we try to do it in the other direction, f inverse takes 1/4 to minus 2. So we set x equal to 1/4, and here, f inverse of 1/4 is minus 2. And if we take that minus 2 and we look in f of x, minus 2 goes back to 1/4. Same thing, 1/2 goes to minus 1. And if you take that minus 1 and you look back into the table for f of x, that takes it to 1/2. If you do the two functions in sequence, first a function and then its inverse, you just come back to what you started with. And that's these two statements. And these will be very important when we deal with exponentials and logarithms. Now, finally, if you have a formula for a function that's got an inverse function, how do you find the formula? And the procedure is switch x and y and solve for y. So y equals 3x minus 6. What's the inverse function? So what we have is we have f of x equals 3x minus 6. We want to find out what is f inverse of x equal to. What's the inverse function? Well, we've got y equals 3x minus 6. So switch the x and the y, and then solve for y. So subtract a 6 from both sides, and then divide both sides by 3. We can do a little simplification. This becomes x minus 3 over minus 6 over 3 equals y, or writing it slightly more tidily, minus 1/3 x minus 2 equals y. And so there's our formula for f inverse of x. 1/3 x minus 2. How do you check your answer? Well, that's what we're just looking at. F inverse composed with f of x. That should just give you x. F composed with f inverse of x should just give you x. So how do we check this? F inverse of f of x is, well, f of x is given by this formula here. So it's f inverse of 3x minus 6. What do we do with that? Well, we've got a formula for f inverse. That's that. It's 1/3 of whatever it's fed minus 2. And it's being fed this whole thing, so that all goes in here. And then if you distribute the 1/3, you get x minus 1/3 times minus 6. Oh, I'm sloppy. Sorry about that. This should be a plus. That 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 should be a plus. That's a minus, but that's supposed to be a plus. Now when we distribute the 1/3, we get x, and 1/3 minus 6 divided by 3 is minus 2, and plus this 2 that comes down, just get x, which is what we wanted. And you can do f of f inverse of x. What does that mean? That means you take the formula for f of x, which is 3 times whatever it's fed minus 6, and you plug into here, right, for the x, the formula for f inverse, which is 1/3 x plus 2. And if you multiply this out, you'll get that equals to x. So sometimes these can be a little bit more complicated. If you look at this, what's the inverse function for this? Switch the x's and the y's, so we get x equals y minus 3 over 2y plus 5. Solve this for y. How do you do that? Well, I'm going to multiply both sides by the denominator. Right? And then these two cancel out, and I can distribute the x. If I distribute this x on this side, I get 2xy plus 5x equals y minus 3. So we multiply both sides by 2y plus 5. On the right side, the denominator is canceled out. The 2y plus 5, I can distribute the x to that, and I end up with this formula. I want to get all my y's on one side, and my x's on the other side. So I'm going to subtract a y from both sides. That gives me 2xy minus y plus 5x equals minus 3. And then I'll subtract a 5x from both sides, and that gives me 2xy minus y equals minus 3 minus 5x. And now I can solve this for y. I'm going to factor out the y. So if I factor out the y from both of these two terms, I'll be left with a 2x. And then if I factor out a y out of here, I'm left with a 1. Right? And you can sort of check that. Y times 2x is 2xy. Y times minus 1 is minus y. And now I just divide by 2x minus 1. So I'll divide both sides by 2x minus 1. These two cancel out, and so finally we're left with the formula y equals minus 3 minus 5x over 2x minus 1. And that's the inverse function.